Hello everyone, welcome to my chemistry channel BL Das, short and sweet in chemistry. Now I am going to explain the topic carbon and its compounds and for the class 10 according to CBSE syllabus. Now it is part 14 where the terms in hydrocarbon. What are the terms in hydrocarbon for 10th class? Because in 10th class only very small meanings are there. In higher class you can read almost all the terms in organic compounds. Now here mainly functional group and homologous series, these are two terms are used and very important for 10th class and higher class also. What is functional group? Functional group means it is an atom or group of atoms. Remember, one atom or maybe so many atoms as a group, and which determine the properties of the particular organic compound. That means the particular functional group, that is any atom or group of atoms, that determines the properties of particular organic compound. Let us example OH. What is OH? Hydroxyl group. That means here it gives the idea, it determines the group, the character of the family, that is alcohol. Alcohol is one of the organic compound family where OH group should be present, and that example see here CH3OH methyl alcohol. And C double bond, see here the carbon should be satisfied. Carbon should be satisfied 2, 1, 3, 1, 4, and this group is called aldehyde group, CHO, or you can write here simply CHO, and that is called aldehyde group, and it gives idea or determine the character or determine the properties of aldehyde family. An example CH3CHO, that is called acetaldehyde. Similarly, if the carbon is attached to only oxygen, where the carbon has 4 valence is satisfied, one side double bond and other two sides single bond, that is called ketone. What is the family of the group? Ketone. Ketone is a family, and here the organic compound that means having CO group, C double bond O group, that is keto group. Example CH3CO, CH3 propanone. Again see, functional group means any atom or group of atoms which determines the properties of that particular organic compound. Alcohol OH, aldehyde CHO, ketone CO, acid COOH, amine NH2. Like this you will see other functional group which indicates the particular organic compound. So I told aldehyde, that is CHO group. Example CH3CHO, acetaldehyde. Now you can see this is acid group, carboxylic acid, COOH. COOH, that means C double bond O and one side OH. You can write here COOH, that is called carboxylic acid. An example CH3COOH, acetic acid. You should remember like this. Acetic acid, what is the formula? CH3COOH. Let's come to this is called halo group. Halo means halogen. Halogen means chlorine, bromine, iodine, like this. So this is called halo. Halo group, halo compounds. Example CH3Cl, chloromethane. How it is named later we will say. Now you remember only chloromethane. Then come to, if there is a double bond, that is unsaturated hydrocarbon, example ethene, C2H4. If triple bond, that is also unsaturated hydrocarbon, C2H2, that is ethine. Now here only remember some that is functional groups in 10th class. When you go to 11th, 12th class, you will learn a larger number of functional group with homologous series. Then question is, what is homologous series? Series of organic compounds of the same functional group. The organic compounds containing same functional group. I told what are the functional group? OH, CHO, COOH, like this. These are called functional group. If the functional groups are same and having same chemical properties, functional group indicate chemical properties. Some functional group determine the chemical properties. If the functional group is same, then automatically they have the same chemical properties. And one member is different from successive member. That means suppose one containing 2 carbon, other successive member containing 3 carbon. Then what happens between two? What is the gap? That is, what is the group difference? That is CH2, methylene group. That is here one member is different from successive member by CH2 group. That is called methylene group. Now see in example alkane, you want to see what do you mean by homologous series of alkane. Then CH4 you know methane, C2H6 ethane, C3H8 propane, C3H8 propane. Now you can see CH4 C2H6, what is the difference? CH2 group. Similarly C2H6 C3H8, what is the difference? CH2. This CH2 group is called methylene group. That means one group is different from the next group of successive group, that is by only a CH2 group, that is called methylene group. It is not a compound, it is a part of the compound. Remember, that is why we are putting a, here you can understand here a CH4 C2H6 that indicate one CH2 group, C2H6 C3H8 indicate one CH2 group difference. As this is called homologous series, we will see other examples of the homologous series of different functional groups. We know alkane undergoes the homologous series. Methane, ethane, propane, butane, pentane, wherever you want to see, you compare between two alkanes, successive alkane, we can find there is difference of CH2 group, that is called methylene group. Then it only undergoes homologous series. Similarly, alkene, what is alkene? Unsaturated hydrocarbon contains double bond. And now homologous series here that is alkane and contains double bond. It contains double bond. Now here CnH2n, that is formula. Then what happens? C2H4 when n equal to 1, and what is the structure containing double bond? CH2 double bond CH2, ethylene common name, only it is existing and all are discarded. And here this is called ethene alkene. What is general 1? What is the IPC general 1? Alkene. So it is ethene. E spelling should be correct. Then C3 when n equal to 3, C3H6, CH3, CH double bond CH2. You can see all the carbons are satisfied by 4 bonds. Otherwise it has no meaning, it is the wrong structure. And there is no common name here, propene. Now you can find these two are homologous series because there is a difference of CH2 group. Similarly butene, CH3, CH2, CH double bond CH2. It also it containing 4 carbon atoms. Each carbon atom is satisfied by 4 valency of 4 valency. That is why it is the correct structure. The CH2 2 2 4 2 3 4 2 2 4 3 1 4. Each hydrogen is counted as 1 bond. And now why it is called 1 butene? 1 butene and next one is 2 butene. 1 butene, 2 butene having same molecular formula C4H8, but structure, arrangement of atoms are different. That is why it is called isomerism. These are undergoes isomerism. Why it is called 1 butene and why it is called 2 butene? See here. Where the double bond, which side is near to end? Because this side, if you count 1, 2, 3, 4, this is far away from this double bond. If you count from this side, after 1 there is a double bond. So from this side you should count, that is the correct one. 1, 2, 3, 4. That is called 1 butene. What is that one? 1 butene. And next 2 butene. See, after 2 carbon, position 2 here, and there is a double bond. So it is 2 butene. After 2 there is a double bond, 2 butene. After 1, this side from, after 1 there is a double bond, that is 1 butene. So 2 butene, 1 butene, what is the difference? That is the position of double bond. That is why it undergoes isomerism. In higher class you should know this is the positional isomerism. So leave it this one. When you go to higher class you will learn so many new things. Then come to alkyne. Alkyne also undergoes homologous series, and where the formula is CnH2n minus 2, and the bond is triple bond. And what is that one? The bond is triple bond. That means here unsaturated hydrocarbon. These two are unsaturated hydrocarbon. So no problem. You should know why it is unsaturated, because here it contains double bond and triple bond. It contains double bond and triple bond. An alkyne homologous is CnH2n minus 2, that is formula, and contains triple bond, and here formula, structure, common, and IPS name. For if carbon is n equal to, because in alkene and alkyne it started with n equal to 2, whereas in alkane n equal to 1 started. So what happens here? C2H2, and what is the structure containing triple bond? CH triple bond CH. See here the valency of carbon that is satisfied, that is 4. See 1 3 4 3 1 4, that means for carbon hydrogen, always hydrogen equal to 1 bond. And what is common name here? Acetylene ethyne. Acetylene ethyne. But after 2 carbon there is no common name after 2 carbon. This is called acetylene. All the names are discarded. So here after one carbon there is a triple bond. So simply you can say propyne or 1 propyne, there is no difference. Simply you can say propyne. Propyne, see the valency are satisfied by carbon. There are 3 carbon. All the 3 carbons are satisfied by 4 valency, 4 bonds. So that is why the propyne structure is correct. Whenever you see the structure is not satisfied, the carbon bond is not satisfied, then structure is wrong. Structure is wrong. The carbon always satisfied 4 valency, 4 bonds, then only that is correct structure. And after alkyne we will see hollow compounds. Hollow compounds, that is called hollow alkane, whether it will follow homologous series or not, whether homologous series compounds are present in hollow alkane or not. We will see now. Before that, you know alkane and alkene undergo homologous series. One member is different from successive member by a CH2 group, that is called methylene group. Now here in hollow alkane also you can observe this undergoes homologous series. First member and next successive member, that is a different of a CH2 methylene group. Now what is the formula? The CnH2n plus 1 X. What is X? X means halogen, chlorine, bromine, iodine, like this. Now formula, suppose n equal to 1, then what here? CH3Cl. You expand it, then here every carbon has 4 bond. So 1 3 hydrogen, one side halogen, that is chlorine. And what is the name? Methyl chloride. And what is the IPS name? IPS name is chloromethane. Remember, halo alkane. What is that one? Halo alkane. So halo means chlorine, bromine, chloro, bromo, iodine, like this. Chloromethane. This is the IPS name, you should remember. And common name only remember methyl. Alkyl group I told before in previous video. What is alkyl? When alkane loses 1 hydrogen, methane loses 1 hydrogen, methyl. Ethane loses 1 hydrogen, ethyl. That means alkyl group, that is a part of the compound, but it is not a compound, it is only a part of the compound. So see here CH3Cl, so it is a part of the chloromethane. Similarly C2H5Cl, if you expand this, CH3CH2Cl, ethyl chloride, and this is chloroethane, because it is 2 carbon containing 2 carbon. If 2 carbon, remember yourself, 2 carbon means ethane, 1 carbon means methane, 3 carbon means propane. So here ethyl chloride common name, chloroethane, that is your IPS name. Now chloromethane and chloroethane, what is the difference of group, methylene group? That is the CH2. So both are undergoes homologous series. Similarly C3H7, when carbon n equal to 3, carbon number is 3, 3 carbons are there, then CH3, CH2, CH2, Cl. You find 1, 2, 3, that is called propyl chloride. And regarding these more things you will learn in 11th and 12th class. Chloropropane, you can see all three are undergoes homologous series and having a difference of CH2 group. Then come to alcohol. What is alcohol? Formula CnH2n plus 1 OH, that is formula, and here CH3OH, that is methyl alcohol. What is the structure? You expand it, and this is the methyl alcohol structure. I told methyl, ethyl, propyl, the alkyl group. You are using when n equal to 1 methyl group, when n equal to 2 ethyl group, n mean number of carbon here, and here what is the name, IPC name, that is called alkanol. Alkanol. Remember, alkanol, alkane, alkanol, methane, methanol, ethane, ethanol, like this. So alkanol means if one carbon, methanol. See, one carbon, methanol, 2 carbon, ethanol, 3 carbon, propanol. Common name, methyl alcohol, methyl, 1 carbon, ethyl, 2 carbon. Ethyl mean CH5, methyl mean CH3, propyl mean C3H7. This is the part of the compound. CH3 is a part of the CH3OH, C2H5 is a part of C2H5OH, and here C3H5, these are called alkyl group, methyl, ethyl, propyl. So that is a difference of CH2 group from one to other by successive difference, that is CH2. So I hope up to here it is clear. Then we will proceed to aldehyde, acid and ketone, and after that I hope it is clear. But remember, this is only a simple knowledge given to you. When you will go to higher class 11th and 12th, if you will read science in 11th and 12th, then automatically you will learn so many new things regarding nomenclature. This is called nomenclature homologous. In a combination, I want to show you what is homologous series in that nomenclature of different type of functional group. So I hope it is clear, and after that I will proceed to aldehyde, ketone and acids. Now aldehyde. What is aldehyde? Aldehyde means RCHO. Then question is, what is R? R is alkyl group. Now R you may put H, or R you may put alkyl group. What is alkyl group? I told in my previous video. Alkane formula CnH2n plus 2. If you lose one hydrogen, then CnH2n plus 1, that is called alkyl. Alkane changes to alkyl by removing one hydrogen. Alkane is a compound, but alkyl is not a compound, it is a part of the compound. CH4 loses one hydrogen, then CH3, and is not a part of the it is not a compound, it is a part of the compound. That is why one bond is indicating. C2H6 again loses hydrogen, it gives C2H5, that is ethyl. So these are methyl group, ethyl group. Now if you say aldehyde, if R equal to H, if you put R equal to H, then what happen here? SCHO, that is formaldehyde. SCHO is, if you will expand this one, then here double bond OH, then formaldehyde methanol. And if you put R equal to CH3, then you expanded this one, CH3C double bond H single bond, acetaldehyde. What is the IPS name? Ethanol. Actually IPS name is alkanol. Alkanol, so it is ethanol. So there is a difference of CH2 group. Carboxylic acid, RCOOH, R equal to H or alkyl group. Now if you put R equal to H, HCOH, if you put a properly expanded way and is shown by the bonds, then HC double bond O single bond OH, then it is called formic acid. You should remember, it is formaldehyde, it is formic acid, that is called methanoic acid. And next one, if you put R equal to CH3, then now here only one carbon, that is why it is methanoic acid, alkanoic acid. So it is methanoic acid. If R equal to CH3, that is called ethanoic acid. Why? Because there are two carbons, CH3, COOH, two carbon ethanoic acid. What is the common name? Acetic acid. So it is CH3COOH. So it is acetic acid. And you can find also formic acid, acid. These are the two acid in conjugative group. So you can find one CH2 difference. That is why it is called, it undergoes homologous series. Ketone. Ketone, what is the formulas? R C double bond O R dash. R also alkyl group, R dash alkyl group, but if you only write same alkyl group, then you can R. If you put R dash means both are different alkyl group. So what is the IUPAC name? Alkanone. What is the IUPAC name? Alkanone. So if there are 3 carbon, what is the IUPAC name? Propanone. And acetone is common name. Acetone is common name. So you should remember here what is acetone, IUPAC. In IUPAC name propanone, common name acetone, and formula CH3COCH3, and structure is CH3 C double bond O CH3. Are you clear? I hope it is clear to you. And here aldehyde, 1 carbon, that is why methanol in IUPAC, 2 carbon ethanol, because in IUPAC I told alkanol. In carboxylic acid, alkanoic acid. If 1 carbon, methanoic acid. If 2 carbon, ethanoic acid. And here ketone CH3COCH3, and here acetone common name, and IUPAC propanone. I hope it is clear. Please remember, when you go to higher class, you will read in detail, and so many new things you will learn there. And hope it is clear, and I can believe you will subscribe my channel BL Das Short and Sweet in Chemistry, and please like and share my channel to any others who need it. And thanks again. Thanks for watching my video, and thanks again to all.